Hi, this is János, it's Real World Audio, and I just finished my hot chocolate, and we are ready to turn on the filaments. So when you first test your baby newborn vacuum tube amplifier, always do it without the rectifier tubes in. So for those of you who have the baby darling and you use solid state rectification, then what I recommend, because you cannot pull out the tubes there, so there as you turn them on, the high voltage turns on at the same time as the filaments. So there what you can do is do not put in the rectifier diodes, do not connect them up, or maybe you can put in the diodes, but do not hook up the secondary for the high voltage. So leave the secondary voltage connection, the high voltage connection, not connected to the power supply, and turn on your baby darling first like that. So here it's very easy. I don't plug in the rectifier, and then it's not going to give me high voltage. Why is that important? That's important because if the filament voltages are not right, or if there's a problem with the amplifier at the heating level, you want to be able to troubleshoot that first. So step one, we want to establish that our heater voltages are correct, and there's no shorts in the filament circuit. So actually about this sequence of on how to turn on first time an amplifier, I made a video about this over a year ago, but now at that time it was just a list, but now I'm showing it to you. So basically, as I showed in the previous video, we have the meter hooked up, and it's very important, the disclaimer, if you do not attempt to do it at home, especially if you are a minor, there's live voltages inside that can kill you. So unless you are not qualified, hands off, you must not do that. And if you do, it's at your own, well, you are legally, responsible for yourself. My advice is explicitly do not do that. I am not legally responsible for any foolishness that you decide to commit on your own. So when we are done with legalities, we can move on to the actual action. So I have the meter at the AC scale hooked up to the primary voltages to monitor what is the exact voltage that the Variac is showing us, because even though there is a voltage scale there, but that it's not 100% accurate. So when it shows like 90 volts, it might be like 92 volt or 88 or whatever. It depending on my actual line voltage, it would change. Going back here, I have another meter that I will use to monitor the filament voltage. So first let's monitor the filament voltage for the 59 power tubes, and here there are these two tabs, and if I connect the meters here and there, then I will read what is the voltage on the filament transformers. And now at the minimal setting, I'm not really reading anything. So now I have to crank up the voltage. First just give a tiny bit, bring it up to 5 volts on the Variac, and on the AC scale it shouldn't move the meter anywhere. So as you see, there's no significant current draw. It means there's no dead short in your amplifier. That's why the Variac is important, because if there's a dead shorts or near dead shorts, then now you would see the AC, the AC ampere scale shooting up, and then you switch off the Variac right away, and then you disconnect it from the power and you troubleshoot and check everything, every connection you made. Where is the short? And most likely you will find in most cases that you left a screwdriver there somewhere and that's doing the short. Usually that's what happens. So now I don't see any shorts at 5 volts, and you see the meter is showing about 5, and here I'm reading, if it can see, 6.9 volts, right? So now if I turn it higher, 10 volts, 20, let's go 30 volts. So you see now the AC ampere scale is showing a tiny bit of consumption, maybe like 0.02 amperes, like 20 milliamperes, something like that. And I'm reading 30, can you see? I don't know. I can't really see what you guys can. Now I can see 33 volts AC. Okay, so at 33 volts, so this is roughly 4 times less than the line voltage. So we are expecting 4 times less secondary voltages for the filaments. So for the 2.5 volt filament, we expect roughly 4 times less voltage. What is that? That's something like 0.6 volts. So am I going to measure 0.6 volts? What is that? So I'm measuring 0.79 volts. That's roughly in the ballpark. And we might say that it's a little bit higher than we expected, but let's crank the voltage higher up and let's see what we are getting. Maybe you can't see from my arm, but the AC ampere scale is creeping up really slowly and nicely as I'm turning the voltage up. That's what you want to see, that it just goes up like that, nice and smooth and easy. You don't want it to suddenly keel over, because then there's a problem. So now we have 50.9 volts. So I will crank it to make it half the line voltage. I will make it exactly 60 volts. Okay, 61.4 volts, close enough. Sometimes you cannot dial it exactly, but 61.5 is roughly half the line voltage that I have here. So here in my home, the line voltage is always between 121 and 122 volts. I never ever measured here in Milan in my home anything other than 121 to 122 volts. So now I'm exactly at 1/2 of the line voltage. So what I will be measuring here is expected to be 1/2. So I'm measuring, look, 1.195 volts. Can you see that? That's absolutely perfect. Basically 1.2 volts at 50% of the line voltage. So multiply that by 2, so that's 2.4 volts. Bingo! That's right, as they would say, right on the money. So right in the expected range, which is 2.5 volts plus minus 5%. There's the specification of all vacuum tubes to keep the voltage within 5% of that expected value. If you are keeping it at the value or a little bit lower to the minus 5%, it's going to live longer. If you keep it higher than the rated voltage, then your tube will live shorter and shorter. And if it's like plus 10% or plus 15 or plus 20%, then your tube will have a very short life. So we want to prevent that at all cost. And now let's measure how about the input tubes, the driver tubes, and for those, let's see, 3.22 volts. Hey, that's a little, let me see, that's 6.4 volts, 6.44 volts, not bad. That's a little higher than I wanted to see, but it shows now that we are getting something similar that we want to work with. So now that at 50% of the line voltage, I have established that the expected voltages when I crank it up to full voltage, full line voltage, input voltage, will be in the ballpark of what I expect. So now we can continue our adventure and turn on the heat. Continue, just slowly, 80 volts, 90 volts, 100, 110, 120, and I try to adjust it to 122. Okay, 122 point. So it's around 122. Yeah, it's a little bit fluctuating, but it's right where we want it. So let's measure now what is the filament voltage. Okay, so maybe let's just clip one on. This will be easier if I clip it on. Sometimes it's a little hard to make contact. Okay, now I measured 2.524. 2.524. That's perfect. This is what we want to see. 2.5 volts, and just that's exactly what I wanted. So what I do here now, take out a notebook and write down the measurements. So 122 volts AC input. So I write it down that this is the case, 122 volts input and 59 filaments, 2.52 volts AC. Can you see? Maybe. Okay, so that's perfect. We don't need to do any adjustments there. So now let's measure the filament voltage for the input tubes. And there we have to measure them after their filament transformer. I also have these resistors that help to drop the voltage, because straight out after the secondaries I'm getting, check this out, 7.3 volts. So that's way too high to feed the tubes. It would really cook them well and truly. And actually they would be able to take it for a short while, operate maybe a few hundred hours like that, so they won't blow up. Don't worry. If you are a first timer, you turn on your tube amp, and even though you are feeding them such massively higher filament voltage to an input tube, they are in no immediate danger unless they are modern production tubes. If they are modern production tubes, there is a good chance that with the turn on, they will just blow up, the filament opens up. But if it's a new old stock tube, they can easily take it. They won't even blink if you subject them to let's say even 30% filament over voltage for just like a few minutes, or even an hour or two or 10. So here let's clip it on one of them and we measure. Oh, that's a little too high. So I'm measuring 6.77 volts. That's too high. So actually, if I wanted to, I could operate these NOS tubes in them, which are 8532. So that's the military version. It's rugged. It's designed to take abuse. So probably they would operate like 5 years like this, 10 years, easy peasy. But if you keep their voltages proper, then these input tubes will last longer than your lifetime. And also they will sound quite a bit better when their filaments are not being overcooked. So here now, let's write it down into our little notebook that the 6J4 filaments are 6.77 volts AC, and what did we read? They were 7.3 volts AC before they were dropped by these resistors. And what is the value of these dropping resistors? These are 0.33 ohms each. So it's 0.66 ohm that is dropping the 7.3 volts minus 6.77 volts, right? So we had here 7.3 volts, and after the resistors we had 6.77 volts. So let's just turn on our mighty calculator and just calculate 7.3 minus 6.77, and that's 0.53. So this 0.66 ohms, that drops us 0.53 volts, right? And using Ohm's law, resistance equals voltage divided by current, we can calculate what is the current draw that is being drawn by the filaments. And how can we calculate that? We divide 0.53 by 0.66. So we divide the voltage by the resistance, 0.80. So it means that the current is 0.8 amperes. So these tubes are drawing, the two tubes together, they draw 0.8 amperes. Is it good or not? So if you check the tube manual, you will see that a 6J4 or any other version of it draws 0.4 amps of current. And we have two of them, 0.4 times 2 equals 0.8. So we are exactly drawing the expected amount of current, which is a huge thumbs up, right? There is nothing else in the circuit that's drawing extra current, and that's also one of your check marks to establish how much current you are drawing. And you can do that either through there, or you can also do that by checking that extra resistor there that I have in the Darling schematics, which is a 100 ohm resistor that I suggest. And that one there, the voltage drops on the primary side. So there the calculations are a little bit more complicated about the current draw, because the current there is for the primary windings current, which is not the same as the current on the secondary. So anyway, that's a topic for another day, how to calculate that. But now we have established that we are dropping the right amount of current, but sadly we are not dropping enough voltage on these resistors, because we are still at 6.77 volts instead of 6.3 volts. So what can we do now? So what I can do, and what I should do and will do, is find a resistor to add in addition to these resistors, or maybe change these resistors to a bigger value to make it big enough so that the filament voltage will be somewhere between about, let's say, 6.15 volts to 6.3 volts. So that's the scale, 6.15 to 6.3. I usually shoot for 6.2 volts AC for a 6.3 volt filament tube, and that's going to give me a good sound and also very long tube life. And just FYI, if you drop the filament voltage too much, let's say you drop it to 6.10, then your tube life will be even longer. If you drop it to 6.0 volts, even longer tube life. But at that low filament voltage, you will notice that the sound is getting anemic. You will lose dynamics, you will lose energy, you will lose drive, and that's because the cathode is not heated up enough, so it cannot emit enough electrons for the electron stream for the vacuum tube. So basically you are starving the tube and it will show. And the other case is when the filament voltage is too high, then you are heating the cathode too hot, and it is just emitting more electrons than it's built to emit, and you are having a problem there. So now we are over 20 minutes. So it's time to stop and time for me to go diving to my resistor box and find suitable resistors to drop the filament voltage. Thank you for sharing this journey, and well, we haven't heard the baby cry yet, and I wasn't crying either, so that's a good sign. And have an awesome day. Bye bye.